Today, we will further characterize a new kind of detector which can sense life energies coming out of the human hand. There's a little yellow loop antenna. When you put your hand anywhere near the loop without touching it, you can see an LED light turns on. What's happening here? Let's look at it from another angle to prove there are no tricks. What is there about the human hand which turns on this detector? We'll find out today in this video in terms of standard physics. First, let us show the circuit being used in this detector. We have an op-amp and a transistor and a loop antenna. Energy is picked up by the loop antenna, goes back into the input of the op-amp, and as positive feedback turns on this red or yellow LED here. Now, in order to make it most sensitive, you have to set the voltage for the LED just below where it turns on. That's at 5.8. I'm going to turn it up a little. 5.9, it's turning on. Let's turn it off again. 5.8. Now, at that level of sensitivity, if we put our hand through the device, it turns on quite easily. Quite remarkable, isn't it? Next thing which we would like to know is which kinds of energies or changes of voltage will turn this device on. We know if we put our hand through it, that will make the LED light up. But what else will make the LED light up? I've made a fairly comprehensive study as summarized on this sheet of paper. Human fingers or hands will turn it on. Mobile phones or Wi-Fi at 2 gigahertz will turn it on. Tesla coil energy at 500 kilohertz, especially if wireless energies go to ground, will turn it on, as I'll show you in a minute. And really big pieces of copper or aluminium. These things won't turn it on. An AC wire coil at 50 hertz, a magnet moving through a loop, DC batteries, or bananas or lemons which aren't very conductive. Let's look at these other examples now to see how they work. First of all, there's no doubt this detector is sensitive to mobile phone energies. Watch what happens when I make a phone call. First the light comes on as the call goes out. Now I'll stop the call, and you can see the light flashes quite strongly for a few seconds when the call's been stopped. And then you don't see anything anymore. Next, we're going to see how Tesla coil energies at 500 kilohertz will affect this detector. We have a laboratory Tesla coil here, which runs at about 12 volts on the control circuit, and very low, we're going to use about 5 watts on the power circuit. So let's turn the voltage up and we'll watch the light come on for the Tesla coil. Now what we've done in this first experiment is we've clipped a capacitor off op-amp input 2 of the detector so we can get AC energies directly. There's no DC, just AC. And you see as the light comes on here in the Tesla coil, it also comes on in the detector. When we turn it off, they both go off. We turn it on, they both go on. Now with 2 capacitors added back to input 2 of the op-amp, the Tesla coil turns on, and we see the light turns on also over there. So it's still picking up Tesla coil energies on, off. on, off. However, we can trigger the detector light to go on and off very easily like that by whether I touch the wire here and ground some energies, which is producing a change of AC voltage going into it. So in summary, this detector with two capacitors added to op-amp input 2 will detect not only the Tesla radiation itself in forms of AC waves across space, but also any changes in the strength of such radiation made by touching a wire here to ground it. When I ground the wire here, you can see this light bulb gets weaker as I ground the wire very slightly. As the light bulb gets weaker here, the detector turns on. Changes of intensity here produce changes of intensity in the detector over here. Also, with no capacitors across op-amp input 2, we can't detect any energy from our hands anymore, whether wireless or not wireless. Adding just one capacitor across op-amp input unit 2 will give us a lot of our wireless signal back. Although it's really weak, we really need two capacitors there. When we add two capacitors back to op-amp input 2, now our wireless detection becomes very sensitive. Whether this is due to the AC waves themselves coming out of my hand or changes in the strength of the AC waves remains to be determined. Summary, this is a very strange phenomenon which needs to be studied further. You can put a DC battery attached to the insulation of the loop antenna and nothing happens until you put my hand up, and then something about my hand turns it on, whereas a 9-volt DC battery won't. That's with one lead attached. Let's attach both leads and see what happens. We have the same DC battery with a red lead attached to the loop antenna, the other lead attached to ground, and nothing happens until I put my hands up. And now you can see it lights up again. So the DC battery itself is much less powerful than the human hand in producing a signal in this circuit. This is a very interesting phenomena which may relate to prana or chi. I don't fully understand it. I'm just providing preliminary data for other people to go further. Thank you very much. With hard work to the stars. It's worthwhile noting that some of the signal input to this device comes from this yellow loop antenna, and some of it can come off this little aluminum antenna over here. But this one over here, you actually have to touch the antenna, and there's nothing wireless, no wireless power. If you want wireless power, you have to use the loop antenna.